the warm-up started with classifying the polygon by the number of sides and then telling whether it's convex or concave. How many sides was it? 6, which makes it hexagon. Is it convex or concave?
Yes.
Convex. Okay. If I extend any of the sides, that's not going to continue into the interior of that polygon. All right, 2 said find the area of the polygon with the vertices. So I plotted the vertices. This is a triangle. How do I find the area of a triangle? Good. 1/2 base times height, or base times height divided by 2, however you want to say that. Okay. The base, I would try to find a side like this one that's actually horizontal or vertical, and this one is. So count it 1, 2, 3, 4, 5, 6, 7. That would be my base. And then for the height, you need something that is now vertical so that it forms a right angle here, which this little segment here is vertical. 1, 2, 3, 4, 5 is the height, and then 1/2 of 35, or 35 over 2. You could also write that as 17.5. Okay. Any of those answers will be accepted. Excuse me. If it was completely rotated and you had to find the area, the length of a base and the length of a height, remember that's where you're using the distance formula. So you did it a bunch in the homework. Hopefully it's now stuck in your brain, but you will definitely have to do the distance formula on your test. Yeah.
Do we have to label the points?
No. All right, this is homework. So 4 and 6, start there. 4 is a triangle, and it is convex. 6 is a hexagon, and it is concave. 8 and 10 ask for the perimeter, so be really careful, because if the test asks for perimeter, you don't want to give the area, or if it asks for area, you don't want to give the perimeter. Make sure you identify which one it's asking for. 8, the perimeter was 12. 10, the perimeter was 10 plus 2 root 5. Yeah.
8 was the perimeter of 12. I got 16. Yeah,
Oh, they all 4?
Yeah.
Just kidding. They are 4. Yep, this would 4 times 4 would be 16. Okay. 10 plus 2 root 5. You'll keep it exact because you wouldn't have a calculator to round it. 12, this one was fun. 12 was 8 plus 4 root 5. Yeah.
Did you do that one?
Yeah. So I looked for the ones that were either vertical or horizontal first that I could count. And that was like this one, this one, this one, and this one. You could count each of those. So 2, 2, 2, 2. And then the longer slanted sides are the ones you actually had to do the distance formula for. So I did ED is this one on the bottom. I did the square root of 0 minus a negative 2, which becomes plus 2.
Okay.
And then negative 2 minus 2, which was that negative 4. Okay. And then I repeated that whole process for the other side. They ended up being the same. They were both 2 root 5. And then you can combine together the 2 root 5s. That would be 4 root 5. And then you can combine together the 2 plus the 2 plus the 2 plus the 2, which is the 8. Okay. Mars.
Can I see number 10? Because I completely did that one. Like, I didn't even do like the shape.
Okay. 14, now we're looking for area of the polygon. So 14 was either 49 over 2 or 24.5 is fine. 6. Nope. 49 over 2 is totally fine. 16, area was 10. Gabriel.
Can I go to the bathroom?
Sure. 18. So I literally found the lengths of all the sides that were not, there was only one vertical one this time. All the other ones you had to find the lengths of. And then 18 asked for the perimeter of B, C, E, F, which you would have added 2 root 2 plus 4 root 2 plus 2 root 2 plus 4 root 2. 12 root 2. 20, perimeter of A, B, C, D. You had to add all the outside stuff. And you could have gotten the square root of 26 plus 4 plus 13 root 2.
I got 21 plus 9 square root 2.
So what are your side lengths? Because you should have had square root 26, right? And that doesn't simplify. Square.
I got like
Square. 4 square root 2, 4, 2 root 2, 4 root 2, 3 root 2.
Wait. Oh, you have to measure like the F and E also?
Because you had it, yeah. You mean
I
F2E?
just measured the distance between A and B.
That's fine too, but you broke it apart. This one just, like, because you had to get the B, C, E, F, so you needed this one. And then the next question was the whole thing. So you could have done it either way. And then 22 was the area of the rectangle. So 2 root 2 times 4 root 2, and that's 16. And then 24, the area of the big quadrilateral. So there's a lot of different ways to do it. I just found the areas of the triangles and the area of the rectangle and then added them together.
I want a hard one. Those were
Yeah.
good. Are they gonna be like that on the test?
You might get like one in which you have to do that much work with it. There's not going to be a ton where you have to do the distance formula, maybe 1 or 2. You don't have to do it over and over and over again. It's a great standardized test question because it takes something and applies it. Yeah. 24? Yeah, so you had to find the area of each of these, right? So if we knew the area of the rectangle, because we had just found it, that one was 16. So that's the area in here. And then I had to find the area of this triangle, which is 1/2. The base, which is 2 root 2, times the height, which is 3 root 2. 1/2 and 2 cancel out, and 3 times root 2 times root 2 is 3 times 2, which is 6. And that's the area of that one. And then I have to repeat that for the one on the bottom. 1/2, the base, 2 root 2, times the height, 2 root 2. So 1/2 of 2 cancels out again, and this time I get 2 times 2, which is 4. And that's the area of that triangle, and then you just got to add all 3 together. Yeah. Yeah.
For the last one I just did, I used the formula for the area of the quadrilateral.
That-
And I got a different one. I got 2 square root 2 plus 18.
So there's no area for a quadrilateral. Which one? What do you think? You're thinking parallelogram or trapezoid?
Well, I looked up the area of quadrilateral because I did the formula.
And what did it tell you?
That it was the length of the bottom base
Times
plus
the height.
length of the top base. And then
Oh, that's a trapezoid.
plus the height divided by 2.
Yeah, so that's a trapezoid. So it's 1/2 base 1 plus base 2, yes, times height. So you did 1, it should have been 1/2 4 root 2, because you have to do the whole thing. Base 1 would be 4 root 2. The whole bottom would be 3 root 2 plus 4 root 2 plus 2 root 2, or was that 9 root 2, times the height, which is 2 root 2. You should get the same answer.
Are we gonna have a parallel trapezoid?
No. I mean, eventually when we get to trapezoids, yeah, but not now. Right, so that's that. And then it's 13, 2 root 2 times 2 root 2, which is 2, and that's 26. It should have given you the same answer. All right, so 1-5 is angles. We've got one more section to go after this, okay? And then we pause for your test, which is Thursday. Test is going to have all the stuff that the quiz had, so I think I'm going to probably be able to give you back your quizzes either today or tomorrow, but you'll get them back. And then section 4, which is what we just did, 5, what we're going to do today, and tomorrow, which is 6. Okay? Yes.
When are you gonna have it?
If not today, I'm waiting to hear back. I did. It's okay. If not today, tomorrow. Okay. All right, so 1-5, again, called angles. Okay, so a lot of vocab at the beginning. Hopefully we know what an angle is. An angle, by definition, is formed by 2 rays that have the same endpoint. The rays are called the sides of the angle. And the endpoint, which is the common endpoint because they both share it, is called the vertex. There are 3 ways to name an angle. By its vertex, and that only works if there's not overlapping angles. So only if that vertex only belongs to one angle, which I'll show you a little bit what that looks like. That you can use just the vertex, like I can call that angle that's there angle N. That's one way to do it. Or the 3 letters in either order as long as the vertex is in the middle. So I could call it MNO, or I could call it ONM as long as the N is in the middle because the N is the vertex. Remember, the sides of the angles are rays. So if it asks you to name the sides, they have to have the ray symbol over them or the word ray. And the order of the letters is important, right? Because the end point is the vertex and the arrow is the end. So it has to be ray, God bless you, ray NM and ray NO. Questions so far? All right, so if your vertex is shared by more than one angle, you can no longer just use the vertex as its name. I cannot call this angle B, because what do I mean? Do I mean this angle B? Do I mean this angle B? Or do I mean this angle B? So you cannot, okay? In that case, you have to use the 3 letters. So there are, like I just said, there's 3 different angles here. The one on the top would be angle ABD or angle DBA. Those are the same angles. Then you've got the bottom one, angle DBC or angle CBD. That's the same angle. And then you've got the big one, angle ABC or angle CBA. So we can no longer use the single vertex B because that angle, that vertex is shared by more than one angle. Okay, interior versus exterior. So the region that contains all the points between the sides of the angle is called the interior of the angle. So interior, think inside, okay? And the region that contains all the points outside the angle is called the exterior of the angle. So the exterior is literally all the way around it, everywhere except for what's in here. And not only what's in that drawing, but what it would be if you kept extending these out. So even though like this point here does not look like it's in the red, if I was talking about interior, if I were to extend those sides out, that would still be in the interior. Any point outside here, here, all of those would be exterior points. All right, remember we had the ruler postulate, which meant we could give a value to something that had length. Now you have the protractor postulate. So a protractor is a tool that is used to measure angle. It looks like this, okay? That's a protractor. And what this says is if you had line OB and a point A on one side of OB, the rays of the form OA can be matched with 1 to 1, with the real numbers from 0 to 180. All it means is that you can measure any angle using the protractor, and that protractor is going to give you the value, as in a numerical value of that angle. That's all the protractor postulate means, okay? When we say the measure of an angle, it means what's the actual value numeric-wise, okay? So if you were to look at this one here, okay, if you could picture, obviously that's my protractor, you always want to line one side up with the bottom, and it doesn't matter if it points to the right or to the left. And then wherever this line crosses through on your protractor is the value. Now, if you look here, there's 2 values, right? One says 40 and one says 140. How do you know which one to pick?
If it's bigger than 90 degrees.
Good. So this one is definitely bigger than 90 degrees. It's called obtuse, right? So I know how to pick the 140. If I wanted to measure this angle, now what angle measurement would I grab? 40, okay. So is it bigger than 90? You pick the bigger number. If it's less than 90, you pick the smaller one. All right, so that protractor, like we just said, is the tool that's used to measure the angle. Angles are always measured in degrees, so it's 40 degrees or 140 degrees. An acute angle is between 0 and 90. A right equals 90. An obtuse is between 90 and 180. And a straight equals 180. All right, this one says find the measure of each angle, then classify the angle. So the first one, GHK, you're going to go in that order, G, then H, then K. What's the measure of that one?
25.
125 degrees, which would make it a
Obtuse.
obtuse. JHK, nope, JHL, J, then H, then L.
90 degrees.
Good.
Right.
Good. And the last one, L,
35.
H. Okay. So how do we find it?
So just subtract the difference of 90.
Good. So you can either do 90 minus 55, or you could treat it the other way, either 125 minus 90. Either way, you get the same measurement. And we said that's what?
35.
No, I'm sorry, the classification, acute, good. Easy stuff, yes? Okay, good. All right, congruent angles. Remember the word congruent means same shape and same size. So these are both angles and they have the same measurement, okay? If they are both 30 degrees, they are congruent, okay? You will see them written a couple different ways. One is without the little squiggle over the equal sign, and this is literally equals. So the measure of angle A equals the measure of angle D, and we use the M and the equals to talk about the actual measure. The other way you'll see it is without the M, but in between is the congruent symbol. And now you're talking about the actual angles themselves. So angle A is congruent to angle D. I don't care how you write it, okay? If it says to write a congruent statement, it's usually going to use the bottom, and it actually gives that little squiggle over equals. They mean the same thing. All right, remember we had segment addition postulate, which said if we take that segment, we break it down into its parts, and we add it back together, we get the whole. Now it's the same, but with the angle. So the angle addition postulate, which we will also shorten a lot to AAP. The other one was SAP, okay? Says if point B is in the interior of angle AOC, then angle AOB plus angle BOC equals angle AOC. So if I take that larger angle, which is AOC, and I break it up into its two smaller angles here and here, if I add those back together, I get the whole. That's it. If angle JKL is a straight angle and point M is any point not on JK, then JKM plus MKL equals 180 degrees. So if you have a straight angle, which is like a line, and then anywhere in between, like the interior there, you draw a ray, then if I take and add up these two angles, it's going to give me 180 degrees. So if I had a straight angle and I had my angle going this way, angle 1 and angle 2 would add up to 180 degrees. If they form a line, they add up to 180 degrees. Good? Yep. All right, an angle bisector. We did a segment bisector. Now we're doing an angle bisector. So the bisector of an angle is a ray that divides the angle into two congruent adjacent angles. So it's cutting the angle in half. And you will know it in a couple of different ways. One, the directions will literally say ray BD is the angle bisector of ABC. So if I'm given that, I know it's cut into two congruent parts. Or ray BD bisects angle ABC. Same thing, okay? Different words, same meaning. Or ABD is congruent to DBC. Or you'll see the picture where you'll have two congruent measurements, okay? All of that would mean the same thing. So if it said that something was the angle bisector and you got given one of its parts, you would know the other was the same. If it said it was the angle bisector and you got given the whole, you would divide it by 2 to get the two parts. Okay, so you'll just see it a bunch of different ways. And these are your congruency marks. So these little arcs here that are red in this picture, obviously not going to be red on your test. They're going to be black and white because your test is black and white. But those little arcs mean that these are congruent angles, okay? These little dashes, the little red dashes here, it means that these two segments are congruent. And then obviously your right angle looks like that, okay? So you're going to have to start reading your figures and knowing what it means. If it's got the little arcs like this, it means those two angles are congruent, and that EB would be the bisector of that angle. If it's got the two dashes like that, it means those segments are congruent. So if this was like 10, this would be 10. If this was 30, this would be 30. So you can start to fill in all that. Well, that wouldn't work either because that would be a straight line. So this would have to be, these would have to add up to 180. This would be 90. So this would have to be 45 and 45.
Why aren't they like together?
Are they what?
Why aren't they like together?
Because they want you to know that those arcs are two separate arcs, but they are congruent. If they were next to each other, you wouldn't be able to tell if it was one fluid arc or if it was two separate ones. You know what I'm saying? Yeah. All right, let's apply it all. You try it. All right, so what's another name for angle DEB? Santi.
Angle DED.
Angle BED. Yep. What else?
You asking me?
Sure.
Angle DED.
We already did that one.
Like the word.
What if you were to use a number?
Oh yeah, angle 4.
Yep. Is angle CEB the same angle?
Yeah.
It is. So you could also use that, okay? It's the ray, remember the ray doesn't end. So it's not as though that angle 4 does not stop at the D. It would keep going, okay? So you could also use that one. All right, CBE could also be called what? It is a right angle, but it wants a name. Well, no, it appears as though it's a right angle. We don't know that it's a right angle, but it appears as though it's a right angle, but it wants a name. Go ahead, Santi.
Angle EBC.
Angle EBC. Good. Nico, did you have a different one? You had your hand up too. Did you have a different one?
8.
Yep. Angle 8. Okay. BEA. Now we're talking about this top angle here. BEA would also be called? Angle AEB. And with a number?
3.
Angle 3. Good. DAB is here. Okay. Could also be angle 1. Could also be angle BAD. Could also be angle CAD or DAC. All of those would be the same angle. Angle 7 could also be named angle ECB or ECA, or the reverse of those letters, ACE or BCE. All of those would be fine for angle 7. Angle 9 could be angle EBA or angle ABE. Angle 7, or sorry, number 7 says angle 1 plus angle 2. So actually, let me clear this off. If I took and added together angle 1 and angle 2, I'd end up with this big angle. So I can call that EAC or EAB or CAE or BAE. Jonathan?
Wait, it could have been
BA, say it again.
Could number 7 be
BAE.
Could include B?
Yes. So it could also be BAE. All right, 3 and 4 would be this top angle here. So that would be angle AEC or angle CEA, or you could use D, AED, DEA. All of those would be fine. And 5 and 6 would be this straight angle here, which would be EDC or CDE. Yeah.
We call it CBD.
C angle 1 and 2. What'd you say? C.
So,
I know, but you number 7 or angle 7?
angle 7.
Oh, sorry. Could you call it what?
CBD.
No, because C has to be the middle. It has to be the vertex.
CBD would be 8.
You see what I'm saying? The C has to be the vertex. All right, last one. Given that the measure of angle LKN is 145 degrees, find the measure of angle LKM and MKN. So LKN is this big angle here. The full thing we're saying is 145 degrees. How can I figure out what these other angles are?
You said it equals to 145?
What equal?
2x plus 10 plus 4.
Good, add them and set them equal, right? So that's the angle addition postulate. It's telling me if I know the big one, then I can take the sum of the two smaller ones, so 2x plus 10 plus 4x minus 3, and set it equal to 145. And then I would combine my like terms, so I'd get 6x plus 7 equals 145. Subtract the 7. 6x would equal 138. Divide both sides by 6. And 138 divided by 6. 6 goes twice. And 3 times. So that's my x, right? But what's it asking for? The actual angles here. So I've got to substitute it back in. Good. If I want to find LKM first, that's the one on the left here. This would be 2 times 23 plus 10. Good. 46 plus 10, which is 56. And then if I wanted to find the other angle, what's one way to do it? Substitute it back in. So the MKN would be 4 times 23 minus 3. How else could I have done it? If I know the full angle is 145 and this side's 56, I could just do 145 minus 56. My advice, if you've got the extra 30 seconds, do both ways and check. Okay. Good morning. So how would this have been different if the information given said that ray M or KM is the bisector of, LKN. Thank you. How would that have changed things if I had said that that ray in the middle was the bisector of that angle?
Nothing.
If I didn't have this information, let's say. If you weren't given these pieces of information and instead you were given the whole thing and then that it was a bisector. Good, okay? So pay attention to the types of information given. If you're given that it's the bisector, we can cut it in half, and then you would know those two. If you're given the whole, but you know nothing about a bisector, you have to do what we just did and add them together and set them equal to the total, okay? Your 1-5 homework is published. It's on Canvas, okay? That's going to be your assignment for tonight. And then tomorrow, hopefully I'll get those quizzes back to you, and we will do the last section. Remember that if you want to do the Quizlet thing, get enrolled in that class, please. That link is on the module of the general information.